In this part of the review, we're going to look at how to add and subtract and multiply radical expressions, okay? So to add and subtract, you first have to simplify all the radicals, then identify the radicals with the same index and same radicand, meaning square root and cube root have to be all separated, grouped differently, but square root of 2 and square root of 3 are also have to be separated and grouped differently. So only when they have the same index and same radicand can they be combined. So square root of 2 plus 5 root 2 becomes 6 root 2. Okay? So let's see how we do it. It's very much like how to do combined like terms. So 3 root 27 minus 2 root 12. I don't know if I can further simplify this, so I have to give it a try. 27 is 3 times 9, right? So 9 is a perfect square, and 12 is 3 times 4, so 4 is a perfect square. So like I said, this square, the 2, and the invisible 2 in front of the radical can be canceled, so that 3 comes out, and there's still 1 3 remain. And same thing with that one, that gets canceled, but the base 2 comes out, and the square root of 3, the 3 remains in the square root. So now I have 9 root 3 minus 4 root 3. I can just do 5 root 3. That's my, root 3 is my final answer there. Okay, another example, number 3, 7 square root of, fourth root of 48 minus 2 fourth root of 3 plus 3 cube root of 72. My God, it's like a tongue twister. So let's try it. I know that there is a 16 in there. 16 is 2 raised to the 4th power. And let me rewrite that. That looks like a 24. Sorry, guys. So let me write that. That's a 4th root. And 2 raised to the 4th power, that's 16. What I have left is a 3 in there. So I'm just going to split them. Minus 2 4th root of 3 plus 3. What do I have? 72. I have an 8 in there. 8 is 2 cubed. 8 times cube root of 9. There's nothing I can do about 9. So now obviously this gets canceled. The 2 comes out. And then the 4th root of 3 stays. And minus 2 4th root of 3 plus 3. This gets canceled. The 2 comes out. And cube root of 9. So I know that this is 14. 14 minus 2. So this and this can be combined. I should have 12 4th root of 3 plus then 6 cube root of 9. That's my final answer there. Okay, so this part is a little bit tedious and cumbersome, but you need to stick with it. Make sure that you have enough practice and then keep going at it. Variables are exactly the same. You handle it the same way. So let's look at number 6, for example. I have cube root, so it's right there. 40, I know I have, what can I have in 40 that's a cube? There is an 8 in there, which is, and it's negative. So 8 is 2 cubed, right? And then it's a 5. So that I just rewrote 40. And 8 raised to the 7th power, I want to write that into something cubed. So it's at least a square cubed, that's 6, and I have 7 a in there. So I leave the last a out, and 2a squared. Then let's do the same thing now. I'm looking cube root of, what can I have for 135? 135 is, if I take out a 5, I have 27. 27 is 3. 3 times 3 times 3, it's 3 cubed is 27. So, and then I said there is a 5 in there. and then a raised to the fourth power is simply a cubed times a, right? So now I start to simplify. Negative 2 comes out, and the 5 stays, and then this a squared comes out, and the one last a stays, plus 2a squared. The 3 comes out, and the 5 stays, then the a cubed, so the a comes out, and then the last a stays. So now what do I have? I have negative 2a squared cube root of 5a plus, this would be 2 times 3 is 6, 6a cubed cube root of 5a. So that's my final answer. If you want to factor the cube root of 5a out and just have negative 2a squared plus 6a cubed times cube root of 5a, that works as well. Okay? So multiplying radicals. Multiplying radicals, you have to use the product rule, which is that you have to have the same index, and then you just multiply them, put them in the same index and radical sign, and then you multiply the radicand. And then you have to simplify. So let's look at how we can do that. So like we said, both of them are square root, so it's simply 27 times 5. Now, I don't like to multiply it out because that's instinctively we pick up our calculators. Instead, because it's a square root, I'm looking for perfect squares. So that 27 has a perfect square in there, right? Which is 9, because that's 3 squared times 3 times 5, and this gets canceled. The final answer is the 3 comes out. Inside is 3 times 5 becomes root 15. Okay, let's look at number 10. I have fourth root, so negative 3 is still there. If I do, be careful, this is a multiply. I thought it was a subtraction. Okay, so double negative becomes a negative, it becomes a positive, so it's 3. And then because they're both fourth root, it's 64 times 8. But notice that 64 times 8, rather than multiplying it out, notice that I have 16 in there, right? So it's 4 raised to the third power times 4 times 2. So 64 can be factored into 4 times 4 times 4, or 16 times 4. So it's really 4 cubed. So because of that, so it's 4 raised to the, I'm going to rewrite it, 4 raised to the fourth power. In this case, the 4 comes out, the base comes out, so your final answer is 12. Fourth root of 2 is the final answer for number 10. Okay, I went a little detour here because I got confused. I thought it was a cube root. It's actually a fourth root, so but nonetheless, you still have to rewrite the 64 into 4 times 4 times 4 times 4, 4 raised to the fourth power, which is right here. Okay? So let's look at the next page. Again, all of these, pick a couple of questions just to familiarize yourself. Anything with a variable in it is a Algebra 2 content. I'm just throwing it out there for your super achievers who wants to be exposed to it. If you have questions, ask, and we will give you additional simpler practices in class as well. Last thing to cover is binomial examples. So binomial examples are fairly simple. It's just distributing. So you have root 10 times 5 times 5 times 5 times root 5 minus 2 times root 10 times 2. Okay, so here if you want to combine, 10 times 5 is really 2 times 5 times 5 again, minus 2 times 10 times 2. I know there is a 2 in 10, so that's 2 squared times 5. And so that way the 5 comes out, root 2, and then this 2 comes out, root 5. You should have 25 root 2 minus 4 root 5. Just be careful, that's a multiply there. That's the final answer there. Okay, no surprises. Still the same thing when it's like number 16. You still have to distribute the 8. Then you have to distribute the negative root 10. So let's see. 8 times 3 is 24. 8 times negative root 10 is that. Then I do negative root 10 times 3 becomes negative 3 root 10. Then negative root 10 times negative root 10 is 10. So I have 34 as the whole number here minus 11 root 10 is my final answer there. Let's do one that's a little bit more challenging. They're actually pretty much the same. Over here, you can either use this property, a plus b squared, perfect square, or you can simply just expand this, 4 minus root 5 times 4 minus root 5. It's the same thing here. Okay? I think that's it. The rest of it should be pretty repetitive. So again, do whatever you can and bring your questions back to the classroom, and we'll give you more additional practices as homework. All right, bye guys.